Okay. So compensation theorem states that in a linear time invariant network, when the resistance of an uncoupled branch carrying a current I is changed by delta R, the currents in all branches would change and can be obtained by assuming that an ideal voltage source of Vc has been connected such that Vc equals to I into delta R in series with R plus delta R. Then all the other sources in the network are replaced by their internal resistances. స్టేట్మెంట్ చూడడానికి కొంచెం పెద్దదిగా ఉండొచ్చు. ఈ 2 ఫిగర్స్ లో మీకు స్టేట్మెంట్ మొత్తం ఉంది చూడండి ఒకసారి. యాక్చువల్ గా ఇదిగోండి, ఇది నెట్వర్క్, సోర్స్ నెట్వర్క్ సంథింగ్. ఇక్కడ ఏదో పెద్ద నెట్వర్క్ ఉంది, హ్యావింగ్ నంబర్ ఆఫ్ వోల్టేజ్ సోర్సెస్, కరెంట్ సోర్సెస్, రెసిస్టివ్ ఎలిమెంట్స్ ఎంతో కొంత ఉంది. నౌ ఆ మొత్తాన్ని మీకు కొంచెం ఈజీగా అర్థం అవ్వడానికి, ఈ 2 టెర్మినల్స్ మధ్యలో ఉన్న నెట్వర్క్ మొత్తాన్ని నౌ దిస్ కెన్ బి రీప్లేస్డ్ బై, this is replaced by a Thevenin's equivalent circuit. I repeat, the entire circuit that is being connected between these 2 terminals is being replaced by a simple Thevenin's equivalent circuit of V0 in series with RTH. Now in between these 2 terminals RL is being connected. Now see the analysis of this circuit. Compensation theorem means now this is the circuit. Here I is the current flowing through this load branch RL. This is the load branch RL. Now initially, when there is no change in resistance of this branch, I is the current flowing through this branch. Simply I equal to V0 by RTH plus RL. V0 by RTH plus RL. Okay. Next, now see this circuit. The same previous circuit, V0 in series with RTH. Now in case of load branch, previously it is of only RL. Now the load branch resistance RL is changed to RL plus delta RL something. Suppose if previously it is of 5 ohms, now one more 2 ohms is being added in series with 5 ohms. 5 ohms in series with one more 2 ohms. That means there is a change in resistance of this load branch. So previously it is of only RL, suppose 5 ohms. Now it is RL plus delta RL. Now delta RL is some 2 ohms is being added. So 5 plus 2 ohms. So now due to change in resistance of this branch, due to addition of 2 ohms in series with this branch, there will be changing in currents and voltages in all other branches of the network. Here the network contains only this branch, but if you assume the big network in between these 2 terminals, because of change in resistance of this branch, there may be changing in currents and voltages of all other branches. Now let us see this branch analysis. This compensation theorem is used to find the, first of all, compensation theorem means whenever there is a change in resistance in a particular branch, now RL is changed to RL plus delta RL. Obviously there will be changing in currents and voltages of all branches. See, this branch and all other branches. So here by using compensation theorem, we are going to find the change in current in any branch. So I repeat, because of change in resistance of this branch, the currents and voltages of all other branches may vary, obviously. So now using compensation theorem, we are going to find the change in current in this branch because of change in resistance in this branch. So that can be found by using this analysis. So after change in, this is before change in resistance of load branch. I equals to V naught by RTH plus RL. After there is an addition of delta RL in series with RL. Now RL plus delta RL is a resistance. In this case, the new current is I dash in this branch. So I dash equal to V naught by RTH plus RL plus delta RL. I repeat, before change in resistance, I equal to V naught by RTH plus RL for this circuit. After change in resistance in this branch, the new current through this branch is I dash equal to V naught by RTH plus RL plus delta RL. Now, how can you find the change in current? Previously, it is I in this branch. Now, it is I dash in this branch. So, simply by taking delta I, which is change in current, delta I, which is change in current in this branch, is delta I equal to I dash minus I. I dash minus I. Here, you can take either I dash minus I or you can take I minus I dash. No problem. If you take I minus I dash, you will get some positive sign. If you take I dash minus I, you will get negative sign. Because I dash is less than I. Because the addition of resistance reduces the current. So taking I dash minus I. So I dash is the formula that we got here. V naught by RTH plus RL plus delta RL minus I means from equation 1 V naught by RTH plus RL. After simplifying this, we are getting delta I as V naught by RTH plus RL. Simplify this later into delta RL by RTH plus RL plus delta RL. Now from equation 1, V naught by RTH plus RL can be written as I. So this can be written as I into delta RL by RTH plus RL plus delta RL. Now I am taking this current I into delta RL as some compensating voltage VC. Now delta I equals to minus compensating voltage VC in place of I into delta RL. VC by RTH plus RL plus delta RL. Now this is the formula. To find the change in current through load branch in which the change in resistance is being applied. So the change in current expression is control voltage VC by polarity doesn't matter. It just indicates that compensating voltage opposes the change in current. Okay, control voltage VC by RTH plus RL plus delta RL. RTH plus RL plus delta RL. Now, so hence compensation theorem tells that with the change of branch resistance, that is RL is changed to delta RL plus delta RL. The branch current changes. So branch current obviously will be changing from I to I dash, and the change is equivalent to change means delta I. An ideal compensating voltage source in series with the branch opposing the original current means here this is the formula to find the change in current delta I in load branch, and in order to find this delta I, the equivalent circuit is drawn from this formula, that is, see here, this is the equivalent circuit which is representing this formula delta I equal to change in current equal to VC by RTH plus RL plus delta RL. So here, in order to find the change in current in this load branch where the change in resistance has been occurred, so in order to find this delta I, this is the equivalent circuit. How to draw this equivalent circuit? Just connect a voltage source. Which is of compensating voltage VC in series with this load branch where the change in resistance has been occurred. Connect a voltage source of value VC, compensating voltage, equal to I into delta R, equal to I into delta RL, in series with this load branch having RL plus delta RL plus delta RL, provided that all other voltage sources should be replaced by short circuit. Here V0 is replaced by short circuit, and if there are any current sources, replace them with open circuit. Now for this case, just find delta I. How can you find delta I? Simply VC by RTH plus RL plus delta RL. That is the formula what we have got here. VC by RTH plus RL plus delta RL. So this is the formula to find the change in current in the load resistance due to change in load resistance, and the equivalent circuit, respective circuit to find change in current is, this is the circuit which is drawn from this formula itself. Okay, now let us see the